Hi, my name is Beshoi Greese and I'm a senior at Lipscomb University. Over this past summer, I participated in a REU at Duke University and Triangle University's Nuclear Laboratory, and I particularly worked with the Nuclear Data Program at Duke University and Tunnel, and worked with the NSDEF and particularly the Carbon-9 NSDEF. What NSDEF is, it just stands for Evaluated Nuclear Structure Data File, and basically what NSDEF is just it's a database of nuclear data, nuclear properties and parameters of various isotopes. And so this database is particularly more important than any nuclear database you could find, is because that it contains a recommended data set of nuclear properties and parameters like decay modes, level energies and radiation properties. And so this data is used for a vast range of nuclear research and applications. And so this makes NSDEF particularly important. And so over the past summer, I worked with my mentor, Dr. John Kelly, on updating the Carbon-9 NSDEF and producing a new and recommended data set for Carbon-9 NSDEF that contains new recommended properties like decay modes, level energies, and radiation properties. And so to do this, we had to go back and do a survey of all experimental data published on the Carbon-9 isotope. Starting with its discovery, going all the way to any recently published data. And so what we found was that Carbon-9 was discovered in 1956 through a survey of nuclear photographic emulsion. And basically what they did was, after striking a photographic plate with 3 GeV protons, they found this decay pattern that had 2 alpha particles, a beta particle, and a proton. And so at that time, they determined that the possible 2 isotopes for this were either Carbon-9 or Beryllium-9. However, Beryllium-9 is a stable isotope, and so it was determined that this was the first occurrence of Carbon-9. After that, since then, there's been 4 half-life measurements of Carbon-9, but I really want to focus on the earliest measurements of Carbon-9 because it produced the first decay scheme of Carbon-9. And what made this so interesting was that it showed that Carbon-9 at that time was a delayed proton precursor, and all that basically means is that Carbon-9 is initially beta unstable and it beta decays to boron-9. However, boron-9 is also proton unstable, and so it immediately shoots off a proton and decays into beryllium-8, and so that was what they discovered back then, but at the time they didn't know it, and then it was found after the earliest measurement of its half-life. And so this is the current decay scheme for Carbon-9, and if you go on the Tunnel website, you can find the current decay scheme for Carbon-9, which is what we have down here. And so this just shows the different energy, the different level states for Carbon-9, and which I talk about here in more detail. The level states of Carbon-9, its ground state is at 3½ and since then there's been a 1½ state discovered, a 5½ state, and a 5½ state, which was the most recently experimentally determined level state of Carbon-9 that was discovered. This 5½ state was discovered in 2019 through a resonant elastic scattering of protons and a boron. However, this particular experiment was interesting because it also says once they fit their data using an R matrix analysis, they found that after including a 7½ state in their data, they found that it produced their experimental results produced a better fit to their data, and so they determined that there is a probable 7½ state for Carbon-9 at around 6400 keV. But their experiment only went up to 6.3 MeV, and so they determined that this is subject to future experimental confirmation, and so this is a probable state. However, it hasn't been experimentally determined. I would like to thank Dr. Kelly and Dr. Alexandra Crowell from Duke University for helping me in coordinating this project and this program, and for advising me throughout this project. I'd also like to thank Duke University and Tunnel for hosting this program. I'd also like to thank the NSF and the DOE for funding this REU, and the DOE for funding the nuclear data program at Tunnel, and for making this possible. Thank you.